Alright, concept D is going to be very similar to what we talked about in our last concept when we did percent composition by mass. Now we're going to be specifically looking at it in terms of what we call a hydrate. Some ionic substances, so compounds made up of metals and nonmetals, can trap water within their crystalline substances. These are called hydrates, and they have a specific ratio of water to salt. So for example, BaCl2 has 2 water molecules that are loosely held and thus has the formula Ba2, 2H2O. So this is dot is not like a multiplication symbol. This is simply the symbol that we use for a hydrate to show how many water molecules are held within the structure of, in this case, the BaCl2. Sodium alum, which you can see here, has 12 water molecules that are loosely held within its structure. So this has the formula of again, the sodium alum formula with this dot indicating the 12 water molecules that are loosely held. These salts can become anhydrous, which means without water, by evaporating the water out of the sample, and we do that through heating it. So our first one is just going to be working with our formula and doing percent water by mass. So in this case, water is our part, and then the full formula is our whole. So what we're first going to do is we have our mass of our water in our numerator, so that's our part, and then our total mass is going to be in our denominator. We're going to see, and I'm just going to do the calculations right in the formula. We have 2 times the mass of water. Water is H2O, so 1 plus 1 plus 16 got us to 18 grams. And the mass of our whole, I've just totaled the sum for you. You would have your 1 barium atom, your 2 chlorine atoms, and then the 2 waters. So you get a sum of 244.3 grams. And then going ahead and solving for that, we get the percent water by mass as 14.7% with this hydrate. Alright, another type of calculation that you need to be able to do is not just using the formula, but also actually using lab results. So a 3-gram sample of a hydrated salt, meaning it's with water, is heated to a constant mass of 2.32 grams. What is the percent water by mass of the hydrated salts? So you first need to figure out the part, which is the mass of your water. Well, if we heated it to a constant mass of 2.32, that means the difference between these numbers is the amount of water that evaporated. So we would simply subtract our starting amount of the hydrate minus the anhydrous salt without water after it's been heated. So the mass of our water is 0.68 grams. So that's going to be our part. And then our whole is going to always be what we started with when the water was still with the salt. So we have then the mass of our water again, the total mass of the sample. We're going to go and plug in then the 0.68 grams that we calculated before, and then again our whole is going to be 3 grams, which is the hydrated salt that we started with before heating. And then going ahead and solving it, we get the percent water by mass is 22.7%. Okay, that's all you need to know for hydrates right now. We'll continue on tomorrow. Make sure you remember to do your summary. Just focus on describing a hydrate and how this connects to percent composition by mass.